students, so new book, new chapters and lot of diagrams in your book. So finally this video is the solution for all your diagrams, and if you are struggling then this is the last resort where you can come. Welcome on the platform Diksha Vedantu, and I am your SST faculty Tanvi Mam. I know that from last few days you were struggling with the new syllabus, new books. All the problem is sorted by uploading one shots, and now it is the high time that we have to deal with all diagrams of class 9. Class 9 students, there are a lot of times when question comes straight from the diagrams, or they will ask you to explain a particular point with the help of diagrams, right? So we have to ace those diagrams because I don't want any of your marks to be deducted in the examination. Okay, particularly the diagrams are taken from two chapters of geography, that is atmosphere and climate and shaping of the earth crust, and we will be dealing it in detail. So let us start with the very first diagram of the day, and that is about the interiors of the earth. But first of all, what you have to understand here is the first chapter, that is shaping of the earth crust, right? Shaping of what? Earth crust deals with two agenda, and that agenda is interiors of the earth as well as exteriors of the earth. The force that is applied inside the earth crust, right? And the force that is applied outside, intrusive force, extrusive force. Okay, that is what basically this chapter is about, and the chapter tells us about how landforms are formed, right, due to these intrusive as well as extrusive forces. So first of all, we'll see the inside of the earth. Basically, this is the perfect diagram which can take us to the interiors of the earth. Let me tell you, there are certain direct as well as indirect sources of information by which we got to know that how is the interiors of the earth, right? So, in this earth surface, beta, in this earth surface, this is the crust area where we people live in. This is what? The crust where we people live on, right? Just below the crust, pay attention to that, how we will see it, beta. So this is the earth, right? This is the earth, as you can see that. This layer of the earth is known as crust. This layer of the earth is known as what? Crust. Below crust, there is another layer. This is known as mantle. This is known as what? Mantle. And under this is core. Okay? Under this is core. However, what you have to pay attention seeing this diagram is that the crust is the thinnest layer. Okay, the crust is the thinnest layer where we live. However, the mantle is the thickest layer. Okay, the crust is basically all hard surface, that means landforms, right? Hard surface. However, the mantle is in molten state. Okay, under it, yeah, or what we can say, at the center of the earth lies the core. In the core also there are two layers, outer core as well as inner core. Okay, outer core as well as inner core. So whenever the question comes that explain the interiors of the earth with the help of diagram, this is the exact diagram you can draw. Okay, or one more which can be helpful to give a more visual orientation of your diagram will be this one basically. Okay, so what we are doing in the form of the slice of pizza, like considering only this part of the earth, we are telling with the help of this diagram that this is core. This is what, bacha, see how we can draw this. Okay, so this is core. In core also there is inner core as well as there is outer core. Okay? Above this lies mantle, and at the top lies what? The crust. Okay, pay attention to that. But if we talk about crust, okay, if we talk about crust, there are two what we can say, two things on the crust. What? One is either the continental crust. Continental crust, that means the place where live the hard rock crust wala, right? Other than that, we have one more thing, that is oceanic crust. Oceanic crust over which water is there. We know that under the water, what it is? Land only. Okay, the thickness of this continental crust is more in comparison to the oceanic crust, for obvious. The crust thickness lies from some around 5 km to 30 km. Less whenever it is oceanic crust, more whenever it is continental crust, right? Then let's go below it. what happened beta, below the crust, okay, pay attention to that, below the crust, just below the crust, there is a layer, okay, there is a layer which is semi-molten, which is in semi-molten state, okay, which is in semi-molten state. This layer is particularly known as asthenosphere, okay, this layer is particularly known as asthenosphere. And do you guys know that this crust along with asthenosphere, okay, this crust along with asthenosphere is known as lithosphere, because that is semi-molten in state. This is known as lithosphere. You can have a look at this diagram. This is asthenosphere, which is in semi-molten state around 200 kilometers in depth. Along with that, it is known as lithosphere. After then continues the mantle and then the core. So this is the very first diagram that you have to understand from the chapter shaping of the earth crust. Then we have more. This is the more clear diagram where it is being stated that how, right, how the forces are applied in mantle as well as core. You can see there beta, there are liquid, whenever there is liquid state, now there will be movement. Obviously whenever there is a thing in liquid state, there will be movement. So in mantle as well as outer core, due to the pressure as well as temperature, there is movement in that what, molten magma. Whenever there is movement in the molten magma, the plates over it, right, the plates, that means on the crust there are certain plate. You might have studied that in plate tectonic theory. If not, go to the chapter, understand it very nicely. Let me give you however a brief introduction about that. So what happened na beta, this magma is in molten state, okay, this magma is in molten state which is continuously moving due to the factor of forces. When they are moving, the crust over it is floating, According to the continental drift theory, what happened, because of this forces, there were drifts in the super continent, that is Pangaea. Hence, we got the continents what we have today. We have two types of plates beta. They are continental plates and oceanic plates. They are floating over this asthenosphere. Okay. However, this is just the brief introduction that this is crust, upper mantle, lower mantle, outer core, inner core. ठीक है, total interior heat flow. As you will go down, the heat will increase, but the flow is outwards. Obviously, the flow will be outwards, due to which volcanic eruption takes place. Whenever there is movement in the plates, that creates shaking of the earth. A lot of times earthquake happens, right? Clear? Chalo, very good. Now moving to the next picture, or what we can say, I won't call it a diagram because they will not ask you to draw this particularly, but I will tell you that this picture clears us a theory, and the theory is about the continental drift theory, basically, that some million years back in the earth, there was only one continent, there was only one landmass, that was Pangaea. That means the North America, South America, Australia, India, everything was just together in a supercontinent known as Pangaea. But what happens, bacha, the tidal impact, tidal effect, what tidal effect? It was surrounded all by water known as Panthalassa. So because of that tidal force, because of the force created by the gravitational pull of sun and moon, as well as the gravitational force which is by earth, all these forces led to the drifting of the earth. By drifting, I means division. The northern part was known as Laurasia and the southern part was known as Gondwana. It further got break because of this drifting into different parts beta, right? And the same goes on and on, forming the current status. See, this is how North America looks like right now, which was the part of the supercontinent earlier. It moved here. It moved towards its left. Similar, we can see the Pacific plate which drifted towards the left as well as south. Similar is with South American plate, it moved southward and then leftward. African plate here, Eurasian plate, Indian plate, Indo-Australian plate, which was together once. Australia moved towards southward and this India moved towards northward, collided with this Eurasian plate, forming the Himalayan mountains. Forming what, bacha? The Himalayan mountains, which is an example of the great fold mountains. Clear with this? So yeah, this is one picture that is given in your book which we should know, by the way. Okay, so now coming towards further with the chapter, there were lot of pictures, right? There were lot of pictures for the landforms that are created by the natural forces. But what happens up till now, the pictures were related to the interiors of the earth. Now we are moving towards the extrusive forces. Okay, extrusive forces that have a great impact in changing the landform, okay, or the shape of landform. Now what happened because of this extrusive forces, right? Because of this extrusive forces which are created by natural agents, okay, which are created by natural agents like running water, right? Running water, wind, oceanic water, right? Rainfall it can be, and a lot of features. There are changes in what? Changes in the landforms. In that respect, we have to understand certain, what we can say, phenomena. In that phenomena, the first one is beta weathering. Okay, the first one is bacha weathering. Now what is this phenomena of weathering? Beta, what happens now? The large rocks, okay, the large rocks, when break down into small pieces at the same place, okay, at the same place, due to some natural factors like heating, cooling, water, wind, ice expansion, etc., or due to certain chemical substances which actually change its composition, or due to the biological plants and animals plants, when the roots capture those stones, and because of their strength it breaks down into pieces, and lot more. But whenever they are breaking down into the pieces, they remain at their place. This process is known as weathering. Okay, weathering can happen by three types. First is physical weathering, as I just told you, that a rock is breaking into two pieces. Simple is that. How it is breaking? Due to heating, cooling, water, wind and ice expansion, because of its pressure regularly affected on it. Then we are moving towards chemical substances. See, rain water comes now. We always call it acid rain. So acid is there. There are certain chemical compositions when which hit the rock, and rock is also formed of minerals. It changes compositions and leads to breakdown a lot of times. Similar is with biological plants, as I told you. But what happens? Sometimes there is a rock, there is a gap in between, an animal die. Any of the animal die there, or the bone is here. Bone is like somewhere there in the rock, creating a pressure on it, and a lot of things. It is just a single example, plant's root as it is given over here. And lot of factors led to the division in the rock, because what happens when we hammer something for a long period of time, right? It drifted apart. Similarly, it is being hammered by the factors like nature, natural factors, chemical factors or biological factors. This picture is also given in your book. This picture is also given in your book. It will not come to draw the diagram, but I want you to be cleared about all the pictures that are given in the book. Okay, hope this is going to be very helpful session for each of the student watching me right now. Now we have more. We will move towards the second phenomena, that is erosion. Okay, that is erosion. Now what happens in weathering? The rocks broke down. Okay, it will further break down due to the natural forces. And what happened? These natural forces like wind, okay, like wind, water, running water it can be glaciers, okay, it can be many more like waves, it can be ocean currents. All of them carry those ocean currents, everything mixed here. So what happened beta, due to their force they can carry those sediments and deposit it at some another place. This process is known as erosion. Okay, in this process of erosion beta, what happens, pay attention to that. In this process of erosion, because of either erosional activity or depositional activity, certain landforms are being formed. Like, let's check the first example of running water. Right, you might have seen waterfalls, you might have seen alluvial plains, and lot of things formed how. So whenever a river is here, river is flowing through the mountains, right? In the mountains beta, the river will find certain hard rocks as well as soft rocks. The soft rocks, because of the pressure of the running water, what happens, it eroded fast, it weathered fast, and hence leads to the formation of several landform features. Like here, water was flowing, here were soft rocks which get eroded, and hence a shape is formed, that is waterfall. Here is a river. Right, in this waterfall, this river is creating the pressure over here. Okay, pressure over here, and what it is formed, plunge pool is formed here. See, this is a river, this is hard rock which do not get eroded, which eroded leads to the formation of this feature, that is waterfall. Again the pressure is created here, a gap is formed here, that is known as plunge pool, and then the river carry it forward. This is the AI image, I can call it, and this is the original image of the same thing. When you visualize both things, it is more clear to you. Next, let's move further. Right, during the course of this river, when it is moving in the plain area or maybe a flat area, what happens due to the presence of this hard soft rock, a river find its way to move, and when this river is moving in the zigzag direction, what happened, it caused a landform that is known as meander. So whenever the question regarding the meander comes, you can draw this diagram. Right, along with meander, there is a lake form that is known as beta Oxbow Lake. What happened, the river is flowing continuously. Here it deposits a lot of sediments, because of this a part of this river gets separate away, and that is what is known as Oxbow Lake. You can see this image of meander and Oxbow Lake. We have lot more. Right, lot more here. So this is the main river. Okay, this is the main river which, due to the presence of rocks, getting divided into certain streams, and that is known as distributary. Achha, by the way, for your knowledge, I am telling you there are two words, that is tributary. Okay, tributary, and the other one is distributary. What is the difference between the same? So whenever the stream, okay, whenever the stream of a river, okay, stream of river joins the main river, what happens? Stream of river joins main river, this is known as a tributary. Okay, but whenever from the main river the streams get diverted, this is known as distributary. Okay, there are a lot of islands and bars form. So we can see that this particular landform feature, pay attention, this particular landform feature is like an island. Do you also know that there is one riverine island in India? Okay, riverine island in India, which is actually a strange landform feature which we usually don't get. Right, this riverine island is Majuli Island. What it is, bacha? It is Majuli Island, that is formed due to Brahmaputra river. Okay, that is formed due to Brahmaputra river, and it is present in Assam, and this is one of the largest riverine island that is inhabited. That means people are living over there. Strange, isn't it? Yes. So this is how we have to cover more diagrams. So here, because of this, oceanic waves and tidal currents, not tidal currents, tides, oceanic waves, tides and currents, what happen beta? Different landform features are formed. Like when you go to beach, you will see that what is happening. So this ocean is bringing the sediments, getting it deposited, forming the feature like what beta? Like what we can say? Beach. ठीक है. The second one is bay. Okay, what is bay? This is ocean, this is land, and in between there is small land. Between ocean and land, a piece of land, that is known as bay. Then this is sea. ठीक है. Fourth one is headland. Headland, that means, see, this particular thing, ठीक है, this particular thing, so which is towards the ocean, the land towards the ocean is known as headland. Then we have sandbars over here, freehand, and then the river. Okay, this is not of use, so this is riverine. Okay, now let us move towards more landform features that are formed because of this river or ocean also. So this is headland. Sometimes what happens, this is a rock. Okay, this is a rock, beta. This is a rock which is being affected by the regular what? Which is being affected by the regular flow of river. The pressure is created on it, and hence the erosional activity is continuous. Whenever the landform feature is standing like it, in between there is a hollow structure. This is known as headland. This is known as headland, and this hollow structure is particularly known as sea arc. It is known as what? Sea arc. Okay, and this is the effect of tides, not rivers. Sorry, I am wrong there. Sea stacks. So this is sea stacks, just a single pillar standing in the ocean. Okay, then we have high tide level. High tide level, this is basically not the feature. Low tide level. Okay, fine. So see, this particular landform feature, you can see the original image. This is known as headland. Okay, this is known as what? Headland. This particularly is known as sea arc. Okay, and the single stone standing upright in the river is particularly known as sea stack. Okay, it is known as sea stack. Get it? And this is how the landforms are formed. We have more pictures related to this that is given in your book, and beta, whenever the question will comes about the landform forms, yes, they can ask you to draw it. So these are the features that are formed because of the glaciers. Okay, melting of the glaciers. This is the first one over here. Okay, so this straight cutting of the mountain, it is known as artery. Okay, then we have cirque. This particular feature in between the mountains, a lake type of feature is there. Then the pass is easy. We have hanging valleys, U-shaped valley. See what happens, there are mountains. Here there are mountains. What happened? Because of the continuous flow of the glacier water, what happened? So basically here the lateral erosional pressure will be created and forming what? U-shaped valley. Many more are given here. See, this is basically this first feature. Okay, this first feature is known as yardang. Okay, and where it is created, this erosional landform is created due to wind. Okay, wind majorly in the region, those regions are not water rich. Okay, they are not water rich region. High water availability is not there, and hence the wind affect the landforms. If this valley type of feature is created in the windy region, then this is known as what? This is known as yardang. Okay, wind is flowing continuously throughout this pass. This rock is standing upright over there because this was the hard rock. Soft rocks get eroded. Okay, getting my point? Very good. So this is it. This is it, beta. This is the actual image. So this is a sandy region. I won't call it sandy region, but mud vegetation is not there. Hence, what is happening? Continuous flow of wind is creating different landforms. The standing upright rock is known as yardlangs. Okay, get it, beta? Yardangs. Next is about deformation hollow. So in this sandy region or less vegetation region, when we find little water in the form of lake, then this is known as oasis. This is known as, beta, oasis. Okay, Barchan dunes. Then one more thing is there, that is dunes. Beta, these erosional activities with the help of wind, which carry the sands, okay, from one place and get it deposited to the another place, creating the landform features like mountains or hills. They are known as dunes. Okay. However, the dunes are of three types, and these image clears us that. So basically the first one is Barchan dunes. Barchan dunes are basically the dunes which are crescent shaped. It is what beta? Crescent shape. So here you can see that this is basically the crescent moon shape. Okay. Then we have another one that is transverse. That is transfer. That at a similar pace, a lot of small as a lateral dunes are formed. Then we have star dunes. Pay attention to that, like this, star dunes. Okay, like this. This is known as what? Star dunes. 3 types of dunes are given in your picture. The same landforms we can see more in the places where limestones are there. Stalactite. Okay, so what is stalactite? This particular one. Okay, below the crust, like the top, not below the crust, in the crust itself, whenever there is hollow structure in between and the landform is stagnant here, lying like this, this is known as stalactite. This is known as stalactite. This is basically a pillar which remained intact over there. There are cave also. Okay, there are caves also. Then stalagmite basically this one. Okay, the below one. The above one is known as stalactite. The below one is known as stalagmitite. Okay, and cave mouth is also there. So basically what happened when the composition of the rock is majorly of limestone, and limestone gets what? Eroded due to certain factors. It can be heat, it can be chemicals, it can be many more things. They form the different landform features which are listed over here. Okay, and this is sinkholes. This is sinkholes. Actual picture of sinkholes look like this. And then we are moving towards the second chapter of geography, that is bacha, atmosphere and climate. That is what? Atmosphere and climate. See, so basically now the question is, ma'am, all diagrams, what do you mean by this? Beta, what happens now? Whenever your geography question comes, right, they will always ask you to support your answer with the help of diagram. Right? If they don't even ask it, now we shall draw it if the similar such diagram is present in the book. If you're feeling that, ma'am, there should be a direct question. If it is not, why should I draw it? No. Okay, to improve your presentation, to improve your marks, you have to do it. Like we have one diagram, or what we can say picture, given in the geography book from the chapter Atmosphere and Climate, which tells us about the composition of the atmosphere. Like in the atmosphere, what it is: maximum nitrogen, that is 78%, oxygen 21%, carbon dioxide 0.04%, and argon plus others are also there. Here comes the most important, the important one. Why? Because it will always be asked in 5-marker question to draw what? To draw the layers of atmosphere. Okay, to draw what, bacha? To draw the layers of atmosphere for 5 marks along with the what? Description too. So, as we know that beta, so this is what? This is the top layer of the earth, that is crust. Above the earth crust lies the atmosphere which is only available in the planet Earth, and hence we all are living. And hence this planet is known as a livable planet. Why? Because of the presence of this atmosphere. Let's see. How is this atmosphere? It is always being rightly said that when we climb many mountains, when we are going upwards, what happens? The atmosphere, because of the atmosphere, right, the density is decreasing. We are not able to breathe. So let's understand the dynamics very nicely. What happened, beta? We divided, according to the characteristics of layer, we divided it into different layers. It starts from troposphere. Okay, it starts from troposphere at the bottom. So the layer of the atmosphere that is connected to the crust here is what? Troposphere, beta. Okay, it is troposphere. The second layer is stratosphere. Let me tell you, beta, all the weather conditions like formation of clouds, the presence of what we can say, the presence of water vapors, everything is in troposphere. Rain happens because of troposphere, etc. Then we move above. When we move above, there is second layer, that is stratosphere. Because here in this layer, there is no weather conditions which can distract the airplanes. Majorly, not majorly, all the airplanes fly here. Okay, the layer between stratosphere and troposphere is known as tropopause. Okay, what it is known as tropopause. One more thing, this stratosphere contains the ozone layer too. Above the stratosphere, there is mesosphere. Okay, mesosphere, the middle line, basically troposphere, stratosphere, mesosphere, the middle line. Okay, meteors get burned over here, because here with what happens, meteors are coming from universe. Okay, there is very less density at exosphere and thermosphere, hence they reach mesosphere. But here, because of the presence of elements, there is a lot of friction and these meteors burn here. Okay, this particularly tells us about the variation in the temperature. Why? Because as we move upward, the temperature decreases. We move more upward, the temperature decreases. We move more upward, the temperature decreases. But here in thermosphere, the temperature increases. The temperature increases. Why? Because of the presence of ions, and hence all the satellites and the communications comes from this layer of Earth's surface, this layer of atmosphere, sorry. And the last one is exosphere, which ultimately merges with the universe. Okay, getting my point? You can also see their height in kilometers. Like when I talk about troposphere, it lies from 8 kilometers to some around 18 kilometers. By this, what is the proof? Because the earth is like that it is bulgy at the, what we can say, center, and not bulgy at the poles. Hence, at the poles, the width of this troposphere is some around 8 kilometers, which increases as we reach the equator. Okay, so this is very important question that you have to understand nicely. This is something we studied in class 6, so I'm not going to explain it very nicely, but still, if you guys have any issue with this bit, I will be bringing a separate video for all the in-depth information. Like if we talk about Earth, we know that it is tilted. It is tilted, and for the convenience of study, we have drawn some imaginary lines. The 0 degree is equator, 23.5 in the north is Tropic of Cancer, in the south is Tropic of Capricorn, Arctic Circle, Antarctic Circle. Okay, whenever the sunlight is directly over the Tropic of Cancer, what happens? Here it is summer season, here it is winter season. But this particular rotation and revolution goes on and on. When the sunlight is directly on Tropic of Capricorn, what happens? The southern hemisphere have summer season and the northern have winter season. So this is how actually the division and the imaginary lines of the earth look like. Okay, one more and important feature again in the chapter, that is atmosphere and climate, that is known as land breeze as well as sea breeze. It is known as bacha what? Land breeze as well as sea breeze. Now, why this topic is quite important? Because they will ask you the topic directly, and even they will ask you to draw and tell it, right? So now let me tell you beta, the heating capacity. You know, you're a science student, you're well aware about that. The heating capacity of land as well as the sea is not same, right? Try to think that which feature of land gets heated more and remains heated for more. Meanwhile, I will have my tea. Okay, I can leave it for 2 minutes, this will not get cold. Fine, coming back to it. So, land breeze and sea breeze, let me tell you beta, during the daytime, okay, be attentive here, we can give you confusion. Here we are talking about daytime. Okay? Daytime, when the sun is overhead. Whenever the sun is overhead, what happens? This is land and this is sea. Okay, this is land and this is sea. What happens? Land gets heated a lot, but it remains heated more than water. It remains heated more than water, and it is warmer than land. The water, what happens beta? You know this. Why? This is so basic thing, right? When there is summer season, we are even moving at 7 o'clock, we will feel that warm winds. Why? Because that land is heated and warm winds are coming from it. So beta, pay attention, during the daytime land is heated more in comparison to sea, and hence here it is high temperature. Whenever there is high temperature, there will be low pressure. Very good. Moving to this one. What happens? Low temperature in comparison to this creates high pressure. Wind always moves from high pressure to low pressure. What happens? High pressure to low pressure. Okay. This particularly is known as what? Because the winds are coming from sea to land. Sea to land, and hence they are known as sea breeze. But the opposite thing happens during the night. Now what happens? Water is warmer than land during the night, because what happens na beta? The speed, okay? The speed at which land gets heated up, it gets heated down also. Now pay attention to this at the night time, but water takes time. Water takes time to get cooled down in comparison to the land, and hence what happened? Here bacha, here there will be low temperature, high pressure, high temperature, low pressure. Winds are moving from high pressure to low pressure, high pressure to low pressure. See here, high pressure to low pressure. And as winds are moving from land to sea, this is particularly known as land breeze. This is particularly known as land breeze. Here was the difference between the land breeze as well as the sea breeze. I hope that now everything is clear to each of my student. Beta, pay attention. Picture based questions, diagram based questions, we should not leave it at any cost, and hence this video was made for you. Apart from this, we teach two class 9th and class 10 students, CBSE students on the channel Diksha Vedantu CBSE English. You can have a look at the teachers over here, join the classes, join the live classes, and basically if you guys feel any issue in your class 9, class 10 preparation, you can feel free to ask me. This was it for today's video, and if you guys need more interactive videos like this, like map work, like ma'am this, like ma'am please tell us about the monsoon of India, you can just write it in the comment section and I am going to make a video on it for sure. Up till then, take care, tata, bye bye.